This is conclusion part one. Um, First point, transverse pulse video. Make a statement about a transverse pulse relating the motion of each separate coil to the slinky to the direction of propagation of the pulse. So if this is the slinky, each coil is going to be traveling um, perpendicular to the direction of the wave. Um, how does the shape of the pulse appear to change as it travels along the slinky? Give reason for the change. As the pulse kind of went along um, it went along the rest of the coil, it got smaller and smaller because of the friction on the ground and the tension. Um, does the speed of the pulse appear to change with the shape of the pulse? No, it was always going the constant speed back and forth between the ends of the slinky, but it just got smaller as it was going along. Longitudinal pulse video. Make a statement about a longitudinal pulse relating the motion of each separate coil to the slinky to the direction of propagation of the pulse. Okay, so in a longitudinal pulse, this is the coil again. It's going to be going, um, each coil is going to be moving parallel to or the same direction of the wave. Um, what is the difference between the observed transverse pulse and longitudinal pulse as it relates to the motion of each separate coil of the slinky? Um, so in a transverse pulse, like I said before, each coil moves perpendicular to the direction of the wave, also the direction of the slinky, and then in the longitudinal, it moves just along it. So if the slinky is going along the floor, the longitudinal pulse is also going to go along the floor with it. Um, Different amplitudes. Upon what does the initial amplitude of the pulse depend? Um, it depends on how far, or in transverse, it depends on how far you move your arm initially to send the wave down the slinky. And in the longitudinal, it depends on how many coils you pull back before you let it go. Does the pulse speed appear to depend on the amplitude of the pulse? No, it doesn't matter because the speed is only affected by um, how tight the slinky is. Frequency videos. Was the wave speed different for the different frequencies? Um, the wave speed was always the same. The frequency was just how often you sent down a new wave. Um, make a general statement make a general statement contrasting the wavelengths at different frequencies. Um, so okay, so higher frequency. So the more often you shake um, the coil, shorter the wavelength because there's less time between each um, wave and they're moving at the same speed. Different distance videos. As the distance between the ends of the slinky changed, the tension in the slinky changed. So the further we were apart, the more tension there was going to be in the slinky, or we could just pull the slinky tighter. What effect did the distance between the ends of the slinky have on transverse pulses? Um, so since we were farther and the slinky was tighter, they moved faster because um, that's just how it works. It's more elastic. Um, did it have bigger amplitudes? It didn't matter if we were further or shorter because the amplitude is just how much you move it initially. What did changing the distance of the tension represent in terms of how waves travel? Um, Waves travel a lot faster with more tension.